So let's remember that to find the critical points, we need to look at where is f prime of x equal to 0 and where does f prime of x not exist. To answer this, we first have to find f prime of x, which means taking the derivative. So which derivative rule will we use here? Quotient rule, because this is a quotient function. So to use quotient rule, I'm going to identify my top piece and my bottom piece. And I'm going to call these capital T and capital B. It's important to remember here, lowercase a and lowercase b are actually constants. So t is equal to a, t prime will be 0, and b prime will be equal to 2x. So if I plug this into my quotient rule pattern, which in terms of t and b is t prime b minus t b prime all over b squared, I get 0 times x squared plus b minus a times 2x all over x squared plus b quantity squared. Now this is a situation where it's helpful to notice that 0 times this is equal to 0. If I simplify this a bit, I will get negative a times 2x over x squared plus b squared. This is my f prime of x. And the question I want to ask is, where is this equal to 0? Now, a quotient is 0 when the numerator is equal to 0. So if negative a times 2x over x squared plus b squared is equal to 0, it must be the case that the top part is equal to 0 and the bottom is not. So I'm looking at negative a times 2x equals 0. Trying to solve this for x, I can divide both sides by negative a times 2, and I get x equals 0. Let's see, are there any places where f prime of x does not exist? So is there anywhere that negative 2ax over x squared plus b squared does not exist? Notice this isn't automatically obvious. Because of this denominator, it's possible that the denominator is equal to 0. And if the denominator were equal to 0, this would lead to not existence. This is squared. And so if x squared plus b quantity squared were equal to 0, then we could take the square root of both sides. We would get x squared plus b equals 0, which we could subtract over and get x squared minus b, which x would then be plus or minus the square root of negative b. This is why it's important to read very carefully, because it says, assume that a and b are both bigger than 0. So if we assume that b is positive, and we're dealing only with real numbers here, then we cannot take the square root of negative b. So this would actually be no solution. And even though it was important to check, there is nowhere, there are no critical points where f prime of x does not exist. So this means that we have our one solution here at x equals 0. This is our only critical point.